In next 20 minutes, you'll be learning what is Litmus, its architecture, how does it work, how to install it, and how do we perform chaos engineering using Litmus. So let me start with the first thing, that is, what is Litmus? Litmus is an open source chaos engineering platform that enables teams to identify potential outages and weaknesses in their infrastructure by inducing multiple chaos scenarios in a controlled way. It is basically an end-to-end chaos engineering platform for cloud-native infrastructures and applications, which is designed specifically to orchestrate and analyze the chaos scenarios in your environment. With over 2 million installations and 68 million plus Docker pulls and multiple chaos experiment executions, Litmus has been used and adopted by 250 plus enterprises such as Red Hat, VMware, Wipro, JFrog, Intuit, and many more. Litmus comes with Chaos Hub, which is an open source marketplace hosting more than 50 experiments. It has options such as targeting your pods, targeting nodes, or doing network chaos, or even cloud specific chaos such as AWS or Azure. Now let's go through the high level architecture of Litmus. So this architecture has been segregated into two parts. So the first is control plane, which consists of microservices responsible for functioning of Chaos Center, which is a web-based portal used for creating, scheduling, and monitoring the chaos experiments. And second is the execution plane that contains components required for orchestration of chaos injection in your target resources. Now through this architecture, let's understand how Litmus exactly works. As mentioned, control plane is used for creating and scheduling chaos experiments, which is a set of chaos faults defined in a definitive sequence to achieve a desired chaos impact on the target resource upon execution. Now, in order to create experiments, users can set up and log into the Chaos Center using the web-based UI. Once the user creates a chaos experiment using Chaos Center, it is then passed to the execution plane. The execution plane interprets the chaos experiment as a list of action that will inject chaos in the target workload. Once the experiment is executed, the execution plane sends the chaos result to the control plane for post-processing using either built-in monitoring dashboard of Litmus or external observability tools such as Prometheus DB or Grafana dashboard. Now since we have understood how Litmus works, let's start with installing the Chaos Center in your infrastructure. So there are two ways you can do it. First is using the Helm chart, or second is using the kubectl. Before we begin the installation, if you enjoyed Litmus so far, we would really appreciate if you could just go to our GitHub from this announcement bar. It will take you to our GitHub repository and you can start it here. Now let's jump to the terminal for the installation. You can also follow this documentation for the installation. I have connected my GCP cluster to this terminal, and the first step in order to install Litmus is you can first add the Litmus Helm repository. So for that I'll add this command which will add the Litmus repository. It seems I already have one. Let me just check. Okay, it seems I already have. Let me create a namespace now. Namespace is created. Now let's install the Chaos Center and other dependencies in this particular namespace. For that we'll add this command and make sure that you have the correct image repository and image tag over here, which is Bitnami legacy, and this is the tag. It will take some time and it will show me the deployed successfully message in some time. And you can see it has been deployed successfully. Let me clear things, and if I do kubectl get pods Litmus, you'll see we are having all the pods up and running. And if I go to check out services, you can see we have all the services up and running. And if you see this front end service, this is where we'll be accessing our Chaos Center. So let me assign an external IP to this using load balancer. And for that, let's go to the documentation. So in this advanced installation documentation, you'll see this load balancer service setup. And let's copy this particular command, which will set the spec type as load balancer in order to get an external IP. for our front end service. Let me paste it here, and let's change the namespace to Litmus. And also need to change the service name. It should be Chaos Litmus Frontend Service. Chaos Litmus Frontend Service, and yeah, and it has been updated. Now if you go to services, you'll see the external IP is pending, and sometime it will assign a new IP to this service, and we'll be able to access Chaos Center on that particular IP. Let me clear this out and check it again. Alright, a new IP has been assigned, and this is the port. Let me load this in the browser now. Once you load the IP in your browser, it will load this login page, and here you need to enter the username and password, and this you can get from the documentation. So in the installation guide, if you go to the accessing Chaos Center, here you will see the default username and password, that is admin and Litmus. Let's enter it here and sign in. Here we need to add the new password. And once you are done resetting your password, it will log you into the Chaos Center. And here you can see this pop-up where it says that we need to enable the Chaos Center in environment in order to create our first Chaos experiment. So we'll follow this, and we'll also show you the entire platform as we move forward in the video. So let's go to the environments. So these environments are basically a place where you install your Chaos infrastructure. It basically acts as an additional level of abstraction in order to categorize your infrastructures. So let's create a new environment. Let's name this development. Then you can choose any of the one, production or pre-production, based on whatever category you want to categorize your infrastructure in. I'll just save for pre-production, and there we go. Now in this environment, I have to add Chaos infrastructures. So the Chaos infras are the target deployment that sits in your clusters, discovering your application services so that we can target them and perform Chaos on them. Let me enable the Chaos, and let me add the name as development infra. And next, so you can choose any of these configuration based on your requirement. You can give cluster wide access if you want to perform and monitor Chaos in all the namespaces in your cluster, or you can, if you want to perform Chaos in a particular namespace, you can go with a specific namespace access as well. I'll be going with cluster wide for this video. So the namespace is Litmus and service account is Litmus, which is already pre-populated. In advanced option, you have an option to add node selector or add a toleration as well if you want to. We'll skip this for now. Now we can go to next, and here we need to download this YAML file in order to deploy our infrastructure in our cluster, and then we have to apply this manifest in our cluster. So let's do that. Let me download it, and then you can copy this command and go back to the terminal. Here I'll just paste the command and change this with the path of the file, and it will start installing your infrastructure and the relevant dependencies in your Litmus namespace, as that's what we configure during configuration of the infrastructure. Alright, it seems it has been installed. Now let me clear everything and write kubectl get pods. So you can see there are few more pods added in this particular namespace, which are exporter, operator, tracker, subscriber, workflow controller, and these are the infra side services which will be responsible for performing Chaos in your target resource. Now let's go back to the Chaos Center and hit done, and you can see it has been connected. Now let me walk you through the other part of this platform. So we have chaos experiments, where we create the chaos scenarios by injecting faults and the probes. Then we have overview, where you get the overall overview of your experiments performed and infrastructures. Then we have resilience probes. We talk about it when we start creating probes. Then we have chaos hub, which is a repository of predefined experiments and faults. So if you go to this chaos hub, you would see different set of predefined experiments and faults that you can combine and create experiments based on your hypothesis. Litmus also provides you a teaming feature, where you can invite your team and assign different roles or permissions based on whatever your requirements are for different members. If you want to use Git as a single source of truth instead of Mongo, you can opt for GitOps model. You can choose if you want to run it locally in Litmus, or you can go with the remote repository where you need to add the URL, branch, and the access token or SSH key. Also, if you want to use your own images and do not want to use the default images provided by Litmus, you can choose use custom values and add your custom image registry and repo over here. In chaos hubs, you can also add your own chaos hubs. If you want to, you can fork the current one and create a new one based on your requirements and add it over here. Let's say we want to add new chaos hub, and then you can continue and add your repository URLs and other details, and it will show up over here. Now let's start creating probe for our experiment. So probes are pluggable checks that are defined in the chaos engine for any of the faults that you create inside of your chaos experiment builder. So these probes are like, you can create it once and then you can reuse it in different experiments. So let's create it. So let's create our first probe. Let's go with the HTTP. Let me name this FE check. So before we move forward with creating the probe, let me show you the target application on which we'll be performing the chaos. So I am using this microservices demo application by JCP, and this is how the architecture of this online boutique application, which has the 11 microservices. And for this demo, I'll be targeting the front-end service. So we'll perform a chaos on the front-end service, and we'll try to make it down, and let's see how resilient the system is with this architecture. And so this is how the front end looks like for our boutique application. If I go to the terminal now, and here I can just clear it out first and then write kubectl get services boutique. So in boutique's namespace, we have all the microservices that I just showed you, and this is the front-end service that we are planning to target. So let's go to the chaos center now and then proceed with creating the probe. Let's keep the timeout as 180, interval 2. We have to keep seconds, 2 seconds, attempt 2, and here we need to enter the IP for the boutique application, and there we go. And in method, we want to just see that if whenever we perform the chaos, if it gives 200 response or not. Cool. I think we are done setting up the probe. If you go inside the probe, you'll be able to see the execution history on which experiments it has been used. And then we have probe configuration that you just configure. You can also edit them if you want to later. Now let's go to the chaos experiments. So the chaos experiments contain the series of chaos faults and probes in order to verify your resilience of your system or a service, whichever you're targeting. So let's create our first experiment. Let's name it FE kill, and we'll select the infra. Then we'll go next. You can choose any of these. You can start with the blank canvas where you can create your own set of chaos scenario. You can also go with the templates which are in the chaos hub, which I just showed you. You can choose any of these. Upload your own YAML manifest if you have one. Now let's go to the blank canvas for this video, and Let me add the fault to this. I'll be doing the simple pod delete experiment to test the resilience of the boutique app. So let me select pod delete, and then here we need to add the app kind as deployment, namespace is boutique, and we are targeting the front end app. Now next is you need to tune the fault. So you can change the chaos duration, and you can also add chaos intervals and everything. All these parameters you can change in order to modify or tune your fault. To know more about it, feel free to read our documentation to get more detailed understanding on what these are and how they can impact. This is the one that we created, and we can add it to the fault, and you can choose any of these modes. These are the modes which shows that how your probe should be executed. It can be start of the test, end of the test, or on the edge, continuous, or on chaos. So I'll go with the continuous. We want to just check if the front end service is up all the time whenever we perform chaos or not. So we'll apply the changes, and then we'll apply the changes, and we'll save it. Alright, now if you click on it, you can see we have the target application, fault is there, and probe is also there. Cool. So all the changes that you made using the UI, you can also see them in the YAML as well. So if you go, let's say here, you can see that your app info is here, the app name is boutique, label is front end. Then you can see your fault configurations and everything. So everything is in this YAML, and you can also edit it from here, which will reflect on the UI as well. Let's go to the visual, and let's run the experiment. So it has started running the experiment, and it will perform 3 steps. First is it will install the chaos, then it will perform the chaos, and then it will clean up the resources. So it has started installing the faults. So let's go to the terminal to check. Let me clear this out, and if I do kubectl get pods litmus, you can see there is one job running, that is fekill. So it has started installing chaos in the namespace. Let me check it again. You can see fekill is up and running, and pod delete has started running. Let me try seeing the pods again. Okay, jobs are running, and I'll keep refreshing the browser in order to see if the chaos has been successful or not. I can see the URL is not loading right now. That means the service might be down for now. And if I go to terminal again and clear everything, kubectl get pods boutique. Okay, and you can see that this has been just restarted. That means the pod kill has been successful. As you can see, the pod delete has been completed, and the probe has been failed. This is because when the pod was deleted, the front end service was completely down, and we were not able to access the front end. So if I go to the pod delete, and if you see the probe, you can see the probe check has been failed. And this is because we didn't got 200 response code during the entire experiment. That means the system is not resilient at all. So this is how you can create your own hypothesis on different set of scenarios that you want to create in order to perform the chaos engineering on your system, in order to test how resilient it is on different type of disasters that may happen due to traffic, due to network loss, and many more other scenarios.